Welcome back, everyone. It's been a long time since I posted a video, so I thought I'd do a quick one to kind of explain why it's been so long and give you a quick update on the upcoming projects. I finished my last episode up right around the holidays, and then the holidays hit, and my wife and I got really busy, so we've been kind of out and doing a lot of that stuff lately. And then I think I mentioned in two or three episodes that the steel supplier I regularly use to purchase either full sticks of steel or partials or drops or rims. They shut down their retail store. You can still buy material from there, but they only sell in full 20-foot or 40-foot lengths. So if I need a piece of material only 2 or 3 feet, especially if it's a larger tubing or something that's expensive, I just hate having to buy a whole 20-foot stick that I'll probably never use up. So I kind of stopped doing that, and what I've been doing, part of the reason why it's been so long since an episode, I've been just trying to source the metal I need for some upcoming projects in other ways, either through distributors that will sell partials or by just looking for used steel. And so I have been able to acquire most of the steel I need for the gantry crane, and I also I'd planned on building a welding bench at some point, but really it wasn't on my radar. But I ran across an opportunity to get some steel that would work really well for the welding table. So I've kind of got enough steel now that I can get going on some of those projects. So I guess a review of what those are going to look like here in a minute. But the other reason why I haven't posted anything for a while, and that is that the other day I was actually headed out to the shop to start on the gantry crane in the first episode for that, and I slipped on the ice and I did a 100% rupture of my quadricep tendon. So I'll show you just a quick clip here of what that's like, or where that.
Okay, so up on the screen here is just a graphical display of basically the front side of human leg. This lower portion down here that would go down to your lower leg. This is your thigh up here. This is your kneecap. So the quad muscle, your thigh muscle, is normally connected to the kneecap, which then in turn connects to the lower leg. And you can see these jagged lines here. That's exactly what I did. That's called a 100% rupture. It means that tendon, which the tendon is connected to the quad muscle, completely tore loose from my kneecap. So that means you can't straighten your leg out or basically do anything with your lower leg. So it's pretty debilitating. All these other little lines here that you can see, what those are these lines here and all these lines here. Those are how they repair it. They put 3 anchors in your kneecap, and then each one of those anchors has, in my case, has 4 sutures off of it, and then they bring those sutures up and lace them into the tendon and the quad muscle to pull everything back together. So that's basically what happened.
So as you can imagine, the recovery from that is a pretty long recovery. Um, the biggest factor is that you can't straighten your leg out for weeks afterwards because the sutures they use to attach the tendon back there aren't strong enough to support the muscle. The quad muscle is easily overcomes those sutures and will tear them loose again. So I've been in a brace that locks my leg straight for quite a while now. Um, I can move around, I can full weight bear on it, but it's still a little difficult to try to get out and do things when you can't bend your leg. So I'm going to try to get out to the shop and maybe do a little bit while still in the brace, but if not, that's kind of the reason why I haven't been posting anything. So enough said on that. I'm going to switch you over to the CAD screen and talk about the 2 upcoming projects once I am back out in the shop.
Okay, so on the screen, the first project I'm going to talk about is the welding table. And the picture here on the screen shows what a typical welding table would look like. They're almost always steel. Um, the plate top can either be solid with no holes in it, varying thicknesses, or in the case of this one, this is a picture of a cast iron table with holes precision machined in them. So this is kind of the Cadillac or the premium of what you would want. Cast iron makes a great material to weld against. There's not a lot of spatter, doesn't like to stick to it. It's very stable as far as heat distortion, things like that, but they're also very expensive. So I'm not going to go that route. I'd love to, but I'm not going to, because I just really can't justify. I don't do enough fixture type work where things need to be clamped perfect before you weld them to justify the cost. So I'll get that minimized and talk about what I'm going to do. So I just did a quick 2D CAD drawing here. These little speckles that you see, that just helps you visualize which pieces are the steel, and anything that doesn't have the speckles, there's nothing there. Since they're exactly the same width apart, it would have been kind of hard to tell what's going on there. So this is a top-down view of the material I'm going to use. I'll scoot up here to give you an in view, and that gives you a better example. So these red pieces, those are 2x4 rectangular tubing, 1/4-inch wall, which if you've ever used that size of tubing and 1/4-inch wall, are extremely rigid. So these are going to be 42 inches long. The red ones, the red and the blue are the same item, just it helps see the difference in them. And these are 2 inches, so the overall width is going to be 48 inches, and then this distance across here is going to be 30 inches. So this is also, the blue piece is also the 2x4 square tubing that it'll get attached to these pieces, and probably not welded solid, because if I start welding all these solid, it's liable to move some. I do want to try to keep it as flat as I can. So there'll be some pretty good stitch welds, enough that you can easily clamp to it. And the reason why they're spaced apart is it gives you kind of the same benefit as having a steel topped table with all those fixture holes in them. So you can kind of see in this, zoom in here a little bit for you. You can see in this depiction here, any typical kind of clamp you would have, vice grips, a Bessie style clamp. This pink line is just basically some fake material. So it'll let you reach down with that clamp in between the tubing to get to the underside, and so then you can clamp it down. If I turn that on, turn that off, that lets you see how the clamp would close down against that. So that's basically what I'm going to do. Put some legs on it, and it'll be pretty straightforward. I'm thinking about possibly even, as you guys, if you remember on the cornhole board project, I used my table saw to clamp some of the wood together because it's nice and flat. So I'm actually thinking about, once I'm done with this, that I would then make a probably a MDF top that that would be kind of mirror this, so it would have slats that lined up across the top of each one of these, and openings in here, and then that could sit on top of this, and then I could use it to clamp wood projects too, also, if need be. So we'll see how that goes. So that's the first project that I'm going to probably do before I do the gantry crane, because then it will give me something to do some welding on, though most of the gantry will probably be done on the trailer. So let me switch over to the gantry crane, and we'll talk about that a little bit. So I want to zoom in here first. This is just a picture of typically what most gantry cranes are built like, with a crossbar between the wheels, the upright that supports the beam, and then they put a couple angular kickers to kind of stabilize the whole thing. And this works just fine, and the reason why these kickers kind of have to be there is, if you imagine if there's down force in this direction, that would want to make this piece bow, depending on how strong it was. So by triangulating it for this piece to go down, these would have to go up, so they would put these in compression. So that's one way they kind of combat that, so you don't have to have really super stout material. So let me turn that off. I'll just zoom back up. So this is design. The one downfall with this design here is it kind of ties up floor real estate. With this structure here, you really can't put anything there. You can't walk through there. So I'm gonna do this style, which is kind of a truss design. If you have a house with, say, vaulted ceilings, you might be familiar with a scissor truss design. So you don't have to have, I won't have to have a crossbar here, because as the forces are pushed down from zoom in enough here, you can see there's the I-beam, the cross section of the I-beam. So as the weight pushes down on this, normally it would try, if this was just a single leg instead of this truss, it would try to spread these legs out, And without that crossbar, depending on what type of material they would be, they could very well bend. But because I've added a second link here, um, when you push down on these, for these legs to go out wider, that means it would have to compress this leg, put this one in compression, and stretch that one. So this is going to be rated when I did the deflection calculations on this piece of I-beam. I'll be able to put up to 1 ton, 2,000 pounds on it, which is more than I'll ever need. So this is I kind of like using square tubing, but I couldn't find enough for the price I wanted. So this is actually going to be 2.5 inch Schedule 80 round pipe, which that's a 2 7/8 OD. So plenty stout. This piece here will be, you can see the dotted line. This will be 3-inch square tube that the upright goes in and the I-beam sits on. And the reason why that sits in a piece of tubing that's slid inside of another piece is the doors on my shop are 12 foot, but the ceiling's higher than that, so I want to be able to get as much height as I want. But I also, if I ever had to, probably won't, but if I ever had to take it outside, I want to be able to get out the door without having to lay it down and drag it out. So turn on a couple layers here. So you can see that this will actually be able to extend out. There'll be a pin here that you can see. They'll just pull out, and then these will telescope up, and that way I can go all the way up to my ceiling height for while it's in the shop. One advantage of this style is it leaves this area open. This is actually right at 6 feet from here. From this point here to the ground is actually 6 feet. So I'm a little taller than that, so I'd have to duck a little bit. It'll let you walk through here if you need to. And it's a 12 foot wide. My doors aren't that wide, but I intentionally didn't want it to interfere with being able to pull things in and out of the shop. My doors are 10 foot wide, 12 foot high. So this is actually wider than the shop doors, so I can just kind of tuck it up. I'll actually probably store it and tuck it up by the door into the shop, and that way if you pull things in the shop, because it will fit through the door, it will clearly fit through this with a foot to spare. So that'll be the width. And then when I want to take it out of the shop, these casters that I have, they're not drawn that sophisticated. These show them kind of being fixed, but the casters I have are swivel casters, so I'll be able to just rotate it 90 degrees, lower the beam down, and take it straight outside. As far as raising and lowering the beam, some of the bottom ones that you can get out there, they have several different mechanisms that it uses to kind of jack this beam up and lock it in place. If I was raising and lowering it regularly, I would probably do that, but given it's going to be probably fairly rare that I ever change that, I don't think I'm going to mess with any kind of a mechanism. We'll see, but I'll probably just, because I can easily lift that with the tractor, I'll probably just lift it up, put the pins in the next position, and lower it down, but we'll see. So that's basically a nutshell of what's to come. I have this piece of I-beam, I have the pipe, I have this pipe, I think I got a line on some tubing. I do have the casters. Those you'll be interested in probably seeing, because they came off of, actually, they were military surplus that came off a jet engine overhaul stand. So they would basically bolt the jet engine to this stand, and it had a rotary table so they could turn the engine, do whatever they want. So anyway, these each individual caster is on a spring-loaded swivel base, and I can't remember, I think there's a rating on them, but based on their size, you'll see when I build it, based on their size, I bet you each caster's probably rated at 4,000 or 5,000 pounds, so way overkill for what this is, but I happen to have them, and that saves me from having to buy the casters.
So that gives you a recap of what's going on, and hopefully I'll get back out to the shop in the next couple weeks or not, so stick around and watch for new episodes, and you can obviously ring the bell, and that way you'll get notified when there's a new video. Thanks.